Hello everyone. In our last sessions, we have done definitions of inverse trigonometric functions, their graphs, their properties, and many other things. Now it's high time that we start with, now today in this session, illustrations on inverse trigonometric functions. Now these illustrations would be only based on the properties what we have done by now. So my first illustration is that show that 2 sine inverse x equal to sine inverse of 2x into under root 1 minus x square. If x is between minus 1 upon root 2 and plus 1 upon root 2. Now when I read this question, what comes to my mind is that why that condition is given, that x lies between minus 1 by root 2 and plus 1 by root 2. Now before I start solving, I'm telling you that if you wish, you can remember this as a formula, provided you remember this with the corresponding condition that x lies between minus 1 by root 2 and plus 1 by root 2. That means whenever x lies between minus 1 by root 2 and plus 1 by root 2, you can use 2 sine inverse x as sine inverse of 2x into under root 1 minus x square. What I'm trying to say is without that condition, you will not have those two sides equal all the time. Okay, now how do we show it? From where do we start? Now, most of the time, whenever we have any such question to prove or to understand, we generally name the quantities. So my first idea could be that I may name sine inverse x as theta. And I will remember the condition that x is between minus 1 by root 2 and plus 1 by root 2. If I write theta equal to sine inverse x, then I will have to write corresponding condition on theta. Normally, if I write theta equal to sine inverse x, answer for theta should lie between minus pi by 2 and pi by 2. But now since condition is given, x lies between minus 1 by root 2 to plus 1 by root 2, I can actually make that domain for theta or set of values of theta more tightened by writing it as minus pi by 4 to pi by 4. Why do I write minus pi by 4 to pi by 4? Because x lies in minus 1 by root 2 to plus 1 by root 2. Now with this I proceed. Now theta equal to sine inverse x immediately prompts that can I go for taking sine on both sides? Yes, you can do that. I can take sine theta equal to sine of sine inverse x, and then sine of sine inverse x I can write as x because everything is in place, and now I will be calling x as sine theta. Now if I proceed from here and I go for cos theta part, which I start with cos square theta, and cos square theta is 1 minus sine square theta, so it is 1 minus x square. Then what I do is I go for cos theta, and cos theta would be actually normally would have been plus minus. I mean one positive value, another negative one. But I'll be picking a positive one because cos theta in minus pi by 4 to pi by 4 is positive quantity. And hence I will be writing cos theta as plus square root 1 minus x square. And then I actually start checking that what happens to right hand side. That was sine inverse 2x under root 1 minus x square. Am I able to show it as 2 theta? That is the proceeding. So in place of x, I write sine theta. In place of under root 1 minus x square, I write as cos theta. Now this is nothing but sine inverse of sine 2 theta. Now what could be your reaction? You may think that can I write 2 theta? Don't jump over the conclusion. Before you check where does 2 theta lie. And then I check 2 theta lies in minus pi by 2 to pi by 2. Now I'm free to write sine inverse sine 2 theta as 2 theta. And then actually what were we looking for? What is your left hand side? Left hand side is nothing but 2 sine inverse x, which is same as 2 theta. That means we have shown that two sides are equal. That 2 sine inverse x equal to sine inverse 2x under root 1 minus x square. Mind you please, this is true only when x is between minus 1 by root 2 and plus 1 by root 2. If you wish, you can remember this as a formula also. But I wanted to give you the proof because to get hold on the substitutions and making right use of properties. Okay, so let us move to the next one. And the next one is that show that 2 sine inverse x equal to pi minus sine inverse 2x under root 1 minus x square if x lies between 1 by root 2 and 1. See now the difference from the previous question. Previous question said x was between minus 1 by root 2 and plus 1 by root 2. And now here x is between 1 by root 2 and 1. So that condition matters. And look at the expression what we are asked to show. that 2 sine inverse x equal to pi minus sine inverse. So there is some change from the previous question. Okay. Perhaps proceeding could be almost similar to what we have done. Only thing is we will make right application of the properties. Fine. Now x is between 1 by root 2 and 1, and I will name theta equal to sine inverse x. Normally, as I said before, theta would be between minus pi by 2 and pi by 2. But the condition x lies between 1 by root 2 and 1 prompts that theta lies between now pi by 4 and pi by 2. Fine. Theta equal to sine inverse x. If I take theta equal to sine inverse x and sine on both sides, will lead to x equal to sine theta. Now what do? We go for cos square theta. Cos square theta is 1 minus x square, correct? That will lead to cos theta. Again, cos theta could have been negative, but in pi by 4 to pi by 2, cos theta is positive, so I'll be picking up only positive square root, and cos theta is plus under root 1 minus x square. Now start with that sine inverse 2x under root 1 minus x square. What does happen to it? Sine inverse of 2 sine theta cos theta. I hope you understand that. X is replaced by sine theta and under root 1 minus x square is replaced by cos theta. 2 sine theta cos theta is sine 2 theta. So sine inverse sine 2 theta. Again, don't jump to write it as 2 theta unless you know the condition on 2 theta. Now where does 2 theta lie? 2 theta lies in pi by 2 to pi. So I cannot write answer for sine inverse sine 2 theta as 2 theta. Correct? So what was the remedy? In our previous sessions, we have done some remedy for this. What do? We rewrite that sine 2 theta, that inside quantity. Inside I mean within the bracket quantity. That was sine 2 theta, and I write it as sine of pi minus 2 theta. And now I say I can write answer for sine inverse of sine pi minus 2 theta as pi minus 2 theta. Why do I say so? Because pi minus 2 theta has to be in the range of sine inverse, and it is in 0 to pi by 2. So I can write answer as pi minus 2 theta. And what is 2 theta? 2 theta means 2 sine inverse x. So this is nothing but pi minus 2 sine inverse x. Now we have found sine inverse of 2x under root 1 minus x square as pi minus 2 sine inverse x. Rewrite this, and that would lead to 2 sine inverse x equal to pi minus sine inverse 2x under root 1 minus x square. Now this question is different from the previous one because the condition changed. Okay, so let us take one more. And the next one is 2 sine inverse x equal to minus pi minus sine inverse 2x under root 1 minus x square. We have to show this when x is between minus 1 and minus 1 by root 2. Now this question also looks like the previous two only, but the condition differs. Condition here is that x lies between minus 1 and minus 1 by root 2. Okay. Now what should be the style of solving? Again, the condition has to be kept in our mind, and I may make some naming there, and I write that sine inverse x as theta. And the condition on theta due to condition on x becomes that theta lies between minus pi by 2 and minus pi by 4. Now, this condition is better actually than minus pi by 2, pi by 2. So, that condition actually decides the interval for theta. Now, I can take sine on both sides of theta equal to sine inverse x, and that would lead to x equal to sine theta. Now, if I go for cos square theta, then it is nothing but 1 minus x square. And I can go for cos theta from here, and that would lead to cos theta as under root 1 minus x square. And I have picked up the positive square root. Why? Because now theta lies between minus pi by 2, minus pi by 4. And if you recall, cos theta right from minus pi by 2 to plus pi by 2, it is throughout positive. So minus pi by 2 to minus pi by 4, in this interval, cos theta is positive, and hence I take cos theta as under root 1 minus x square. Now start with sine inverse 2x under root 1 minus x square. Write for x as sine theta, and for under root 1 minus x square, I write as cos theta. And hence I get sine inverse of 2 sine theta cos theta. Now 2 sine theta cos theta would be replaced by sine 2 theta. Now again, like previous two questions, don't jump over to write it as 2 theta. You will have to check condition on 2 theta. Now where does 2 theta lie? Because theta lies in minus pi by 2 to minus pi by 4, 2 theta lies in minus pi to minus pi by 2. And minus pi to minus pi by 2, this interval is not the range of sine inverse. And hence, for sine inverse sine 2 theta, I cannot write answer as 2 theta. So what is the remedy? The remedy is that you try to rewrite sine 2 theta. And I will write it as, now this step is extremely intelligently written step. I write this as sine inverse of minus sine pi plus 2 theta. Now, why do I say so? Because sine pi plus 2 theta is minus sine 2 theta. And outside one more minus sign is written. Right? So, minus of sine pi plus 2 theta is going to be sine 2 theta, which can be very well replacement for sine 2 theta. I hope everyone understands what I'm saying. I'm writing sine 2 theta as minus sine pi plus 2 theta. And sine inverse of minus something was minus sine inverse. So, this is further written as minus sine inverse of sine pi plus 2 theta. Now, many of you would think immediately that, okay, I will write it as pi plus 2 theta. But before doing that, check where does pi plus 2 theta lie. Now, pi plus 2 theta lies in the interval 0 to pi by 2. So, you are safe. You can always write that sine inverse of sine pi plus 2 theta as pi plus 2 theta. And hence, further simplification leads to minus of pi plus 2 theta. Correct? And now, I will write that theta as sine inverse x. So, this becomes minus pi minus 2 sine inverse x. And one more step, rewrite again. And that leads to 2 sine inverse x equal to minus pi minus sine inverse 2x under root 1 minus x square. Now, this is the result provided x lies between minus 1 and minus 1 by root 2. Now, 3 questions I have taken. And in all 3, actually, we were writing answers for 2 sine inverse x. I hope you are seeing the uniformity in all 3. That all the 3 questions we have written for 2 sine inverse x, but in different conditions. So if you wish, you can remember them as formulae, but frankly speaking, it would be a long list to remember. So don't remember that as a formula. You can actually verify on the spot also. Now, when I come in the next session, I will be bringing more problems, more properties. Till then, stay tuned. Thank you.